still? I'm on full screen now. You can
Yep.
still see my screen? Yeah. Perfect.
Absolutely.
All right. So my name is Michael Hausenblas. I'm a developer advocate in the OpenShift team. And my background is on one hand containers, Kubernetes and stuff. But on the other hand, before that, I was at a startup called MapR. And they did essentially a lot of big data, fast data, that first hype phase when, Hadoop was the cool new thing. And there, I saw a lot of things, the handoff between data scientists and data engineers, essentially. So I assume we're all more or less familiar with the second part, with the handoff between, or the cooperation between developers and ops folks. But there is, if you look at teams that want to write or deliver a machine learning feature, there is a second gap there. And that's what I call this double divide, and that is between data scientists and data engineers. If you look at the concrete situation, someone might be using, I don't know, R or even Python, doesn't matter. And they, the data scientists, they put together a wonderful model and they have all their parameters sorted. They have something that works on their machine. And then come the data engineers and developers that actually write the application in PHP, in Rails, in JavaScript, in Go, Scala, whatever. And they very often need to re-implement this machine learning model that has already, the data scientists had that already working, and that causes friction. That means that if something changes, if data scientists iterate and have an even better model with, a better cost function or whatever, the data engineers and developers need to play catch up with that. And KAML really focuses on that. Bridging that gap, helping data scientists on the one hand and data engineers and developers on the other hand to work together better. So very high level typical use cases would be, as a data scientist, you can iterate on your feature, on your machine learning based feature faster, and consequently ship the feature faster. Sharing these data sets and models with your colleagues, with your data engineers, developers, you're working together to actually get that into prod. And if you are a data scientist and think of how you are going about versioning, if we would be in the same room, I would now say, please show of hand, but you can nod or say +1 on the chat or whatever. Whoever has not done that, copying a data set, appending a version 1 or the current date or whatever, doing that again, adding something, removing something, sharing that with others. And there is a solution for that, right? In code, we use Git. We use nowadays typically distributed version control systems like Git that take care of that automatically, whenever we say take a snapshot of the current code base, then a trail, an entire set of histories is built up, and we can go back in time. And the same is possible for data sets. I'm going to go into that in a moment. If you're a data engineer or a developer, then you benefit from the unified way of how KAML handles the data set and the models. And again, think of you might be implementing version 1, data scientists are on version 2, or refining the model or taking a different approach or whatever, and you want to be able to pick up that as quick as possible. And also for ops folks, to a lesser degree, it provides the guidance to run the app optimally with the machine learning features enabled. So far, this is very, very early phase. As you can see, I haven't got any running code yet. The UX is more or less as follows. You have essentially 4 tabs, and that might well change. I might actually had a discussion with Graham, who presented, I think, 2 months ago Jupyter Hub on the Commons video channel. I might actually swap that out. I might actually make these tabs part of Jupyter Lab. So essentially turning it around. But essentially you have these 4 tabs. You have the data tab, where you as a data scientist mainly would upload the data set. You can point it to somewhere on the web or just upload it from your local drive. And then you have 2 ways that's essentially the metadata level, to search for data sets. You have an Elasticsearch back index there. So if you just type in, finance, then this finance data set would be highlighted, or the list would be would show that one. Or you can enter a SQL query, and that would go via a different path through PrestoDB. So you can query, and then anyone who has been working in a real-world situation knows there are typically many data sets you're dealing with. So you can very quickly find a relevant data set. And whenever you want to, you can, that's this green check mark here, essentially take a snapshot of the data set. This is a copy and write snapshot, and essentially only captures the diff. So if you, for example, you have a CSV file and you say, due to whatever reasons, I want to only take half of it, or you have this typical training and test split between 70-30 or whatever, you can do that with one mouse click essentially. And the second tab would essentially be currently the idea of having Jupyter Hub there, or as I said, if I turn that around in terms of UI, it would be the other way around, but essentially having the development mainly for data scientists to essentially put together their model. The third tab would be the deployment tab, which is mainly for data engineers and developers and ops folks. And observation would essentially be Grafana and Jaeger be embedded there. And in terms of components, as you can see, there is pretty much everything besides the actual workbench, which, as I said, now I'm pretty convinced I'm going to do that as a plugin in Jupyter Lab. Everything else is there, right? So you can run it on any cloud platform. We're using Kubernetes, or in our case, obviously, OpenShift as the runtime environment. .mesh is essentially that thing that takes care of the snapshots, essentially what Git does for code. And then you have the two paths for the metadata hub, which is PrestoDB, a distributed query engine that exposes a SQL interface against any kind of storage, block storage, or whatever, and Elasticsearch that captures the other bits of the metadata. On the right-hand side, you see, if you're familiar with Kubeflow, that's essentially Kubeflow. So no big surprise there. And just a final note here, depending on your role, you would probably not see all the tabs. So a data scientist might only see data and development tab. A data engineer or developer might see development and deployment. Ops person might see all of them, or observation and deployment. So depending on your role, you would see different tabs there. Yeah, and that's pretty much it. And now I'm very, very open to feedback and questions.
Yeah, can you put that architecture picture back up, and maybe also explain a little bit about what .mesh is, because I think that's the new component in
Right. Not everyone might know that. That's a really good point. Thank you, Diane. .mesh is essentially a new, it's the first, as far as I know, the first representative of a new kind of mesh, in this case a data mesh. You might have heard about service meshes like Istio or Confluent and others. But .mesh is a data mesh. And data mesh essentially means in the same way you're externalizing functionality in the service mesh with respect to service and networking, you're externalizing functionality in terms of data, in terms of snapshotting data into the mesh. And the mesh takes care of that essentially. So technically .mesh in Kubernetes is a flex volume that just transparently works there. You don't really notice it. You're just using your normal volume there. And there is an API. So working together with the .mesh folks there, with Luke, there's an API, a Python API that essentially allows me to say, take a snapshot of that volume or whatever, and then I can provide that back in time. So you can imagine that at some point in time, you would have a tree-like structure. If I click on that finance transaction data set, I would see this tree-like structure of snapshots that I've taken, or whoever in that context has taken. Makes sense regarding .mesh, or any questions what .mesh can do?
It looks like Carol has a few comments in the chat. Maybe if you unmute yourself and.
All right, I will. Should I stop the screen sharing? Probably.
Yeah. So Carol, say what you
Oh, I was just going to say,
Everybody
Michael, I loved the way you framed the whole process into the 3 groups, because I think that was what I was struggling to articulate the other 2 times that I have sat on the Kubeflow stuff, because looking at it as a data scientist or somebody who's interested in scientific reproducibility, as a data scientist, I want to be able to run whatever I want to run on R, Python, Julia, and install the libraries that I need to get my work done and access the data sets that I need. And in terms of UI, UX, whether that's Jupyter Lab, Jupyter Notebook, Zeppelin, whatever, that's what I want to see as the data scientist. I don't care as much about the although I might want access to it, I might not care as much about the lower, like what I would say, like more a service level, like Jupyter Hub, which lets me deploy it to a research computing group or a team of users or analysts in a Wall Street firm. And then I see Kubernetes being under that still. So I think you've done a good job of capturing some key differences between the different user stakeholders.
Cool. Yeah,
Thank you.
I had a brief question about, I mean, people tend to draw this diagram. I've seen this diagram in incarnations before, and they tend to draw it like waterfall style, like you did. But I mean, like, as a model jockey, if I'm playing that role, I mean, I'm also very driven by what data engineering can like give me, and I'm just wondering like if there's any consideration given to kind of like the arrows that might be going in the other direction, where I can't train on stuff that somebody can't tell me how to federate.
Right. No, absolutely. That's an excellent point, and you're absolutely spot on. Yeah, the arrows obviously go. It's not a from one side to the other. I think I had it a little bit in the description. This iteration bits, right? So you're going back and forth, and you get feedbacks. Like someone just deploys that in production, you go like, yeah, that seems to work in that region, but not really there. Can we somehow update the data set, the model, or whatever? Obviously, yes, it goes in both directions, and I will certainly take that on. Thank you, Eric.
questions or on this?
I just think, following up on what Eric just said, the ability as a data scientist to access different data stores, which might have different authentication barriers, in terms of, I'm at this university, I may be able to access this data, but not, the one over here at this other university or whatever, HIPAA compliance, things like that. I think the data scientist wants a view into that data engineering level. They just don't want to be the person to necessarily do it.
Right. And as I said, I am not aware of any metadata, like open source metadata project that actually does that. This fits with Elasticsearch and PrestoDB. So if anyone has anything there, that my goal is always to implement as little as possible. Right? So if anyone has any project that I can use, then yes, please. But I haven't found it.